Hello guys, hope you're okay wherever you are. Let's try to look at this question, which is for pharmacy second year under elimination organic chemistry, which is acid-catalyzed dehydration of alcohol. So look here, 2,5 dimethyl cyclohexanol undergoes acid-catalyzed dehydration as shown. So now what are we going to do? Write a reaction mechanism to show how the two compounds are formed. Which one is the major product for the reaction? Give a reason for your answer. So now let's try to go through this question. Now guys, when you're given such a question, this is it is in a ringed form and you have OH there. So whenever you're going to be given acid there in a ringed form, you should know that it is E1. Whether maybe methanol acid, it is E1. So now what am I going to do? First of all, I'll say OH is the bad leaving group, so I'm supposed to protonate it or to add a proton for me to have water, which is a good leaving group. So here I'm going to say, let me bring this OH2 with a positive there. Then I'm going to use these lone pairs there to come and grab this hydrogen. Then the bond will go. So what am I going to have here? I'm going to produce water. Remember, don't forget about that. So here I'm going to form something like this. So it will be, okay, sorry. I'm going to form something like CH3. And here CH3, then remember there is a OH2 here with a positive plus water like that. So when I reach there, what am I going to do? I'm going to say this now. Okay, let me rub it, let me write it well. So this now okay, so here there is CH3, then here there is OH like this one with a positive like that. So what am I going to do? I'm going to show that this OH or this water here, which is a good leaving group, it will go. So I'm going to show this bond like this has gone like that, then giving me something like this CH3, even here CH3 like that, then with a positive here. So the moment I'm going to reach there, I'm going to say okay, let me do this. Okay, so I'm going to bring now this water which is here. I'm going to bring this water which is there, so that it will act, that is the one which will act as a base here, which is the base that I'm given. So I want to get rid of this carbocation by adding by removing a hydrogen and create a double bond. So what am I going to do? So remember here there is a hydrogen there, even here there are two hydrogen there. So what am I going to do? So I'm going to bring water there, which is like this, then with these bonds there. So now I'm going to say, what if it's a Z-save, which is when it is Z-save rule, I'm going to attack or to obstruct the proton, or to I'm going to obstruct the hydrogen, which is less exposed hydrogen, which is being hidden by the alkyl group. So now what am I going to do? I'm going to get this and attack this, which is I'm going to attack or to obstruct this hydrogen, which is less exposed hydrogen there. So when I attack, what will happen is that this one will form a double bond there. So how am I going to show that it will form a double bond there? So it will be like this. There it will form a double bond. So here the first product, it will be like this. Here it will be CH3, then here it will be CH3, then with a double bond which is here, then plus this the same water there. I'm going to use it and attack the hydrogen here. There are how many hydrogen here? There are 2 hydrogen which are here on this carbon here. So I'm going to attack this, which is more exposed hydrogen, and what will happen is that it will form a, wow, what have I done? Please, what have I done? Okay, so it will be like this, like this, like this, like this. Okay, it was like that. Okay, it was like that. Okay, so now I can do like this. Sorry, I can do like this. Okay, so when this hydrogen, which is more exposed hydrogen, there are 2 hydrogen, but here there was one hydrogen, it is going to make a double bond there. So what am I going to have? I'm going to have something like this. Okay, because I'm going to have something like this. So here there is CH3, then the double bond will be created where? Here, like this. Then what am I going to do? I'm going to add it. So when you grab the hydrogen to water there, you're going to have an acid like this. That's the one that you're going to have at the end of the day. So this is how we are supposed to write a mechanism for this question. So what am I going to do? Let me try to answer the next question. They're saying, which of the following, or which one is the major product for the reaction? Give a reason for answer. So looking at the base that I've been given, which is hydronium, there, it's a less bulky. So when it's a less bulky, it will favor attacking the one which is less exposed hydrogen, which is this one which I've attacked at first there. So this one, the one which is less exposed hydrogen, is the one that I've attacked with this less bulky, and that's the one which will be called a major product. So a major product, so there is I here and also J. So let me just do this. Okay, let me just do this. So here there is I, then here there is J. So I will be a major product and J will be the minor product. So what is the reason that you can give why I is the major product? Because of the use of a less bulky base which has favored obstructing the less exposed hydrogen, giving the more saturated alkane which is more stable. So that's the how we are supposed to answer this question, guys. Thank you.